Our brain is not fixed. It's constantly rewiring itself based on what we do, what we focus on, and how we respond to our environment. Today, I want to show you how to take control of that process. Whether you're struggling with distractions, procrastination, or simply want to reach a higher level of performance, the key lies in understanding how your brain shapes focus and productivity. We'll explore how simple science-backed methods can strengthen neural pathways, enhance dopamine-driven motivation, and create lasting patterns of deep work. By the end of this talk, you'll know how to direct your brain to work for you, not against you, and unlock the focus and energy you need to excel in any area of life. The brain is not a static organ. It is constantly reshaping itself through neuroplasticity, the process by which neural pathways strengthen or weaken based on repeated behaviors and experiences. Each time we focus deeply on a task, we are reinforcing specific circuits, essentially teaching the brain to value that activity and make it easier to access in the future. This means that focus is not just a skill, but a trainable state, shaped by deliberate practice and intentional habits. When we repeatedly expose ourselves to distraction, the brain wires itself for fragmented attention, but when we engage in sustained, single-task work, it rewires for depth, clarity, and efficiency. Neuroplasticity operates on a principle of use-dependent change, meaning what you do most becomes what your brain defaults to. By understanding this, we can leverage small, consistent actions to build stronger focus networks and dismantle patterns that sabotage productivity, allowing the brain to adapt in ways that align with higher performance and mental clarity. Dopamine is one of the most powerful chemicals in the brain when it comes to driving focus, motivation, and productivity. It acts as a reward signal, released whenever we experience a sense of progress or achieve a small win. This release does not just make us feel good, it strengthens the neural circuits associated with the behavior, making us more likely to repeat it. When dopamine levels are managed correctly, we feel energized, engaged, and capable of sustaining effort over time. However, when we rely on shallow, instant rewards like constant phone checking or random scrolling, we teach the brain to seek short bursts of dopamine instead of long-term fulfillment. To rewire the brain for lasting focus, it is essential to associate dopamine with meaningful progress and effort-based rewards. This means breaking tasks into smaller milestones, celebrating incremental achievements, and training the mind to link satisfaction with the process itself rather than external, fleeting sources of stimulation. Circadian rhythm plays a crucial role in determining when the brain operates at its highest capacity for focus and productivity. This internal biological clock regulates alertness, energy levels, and cognitive performance throughout the day. In the early morning, the brain experiences a natural rise in cortisol, which, when paired with proper light exposure, promotes a heightened state of wakefulness and readiness for mental tasks. Mid-morning to early afternoon often marks the peak window for deep, focused work, as neural activity and dopamine levels are optimally aligned. Later in the day, the brain shifts toward processing and creative problem-solving, making it ideal for brainstorming or planning sessions rather than heavy analytical work. Disruptions to the circadian rhythm, such as poor sleep habits, late-night screen exposure, or irregular work patterns, can impair focus, slow neural processing, and diminish motivation. By aligning demanding tasks with these natural cycles, the brain can be trained to perform at a consistently high level while conserving mental energy and avoiding burnout. Visual focus is one of the most direct ways to influence mental focus because the brain's attentional systems are closely linked to where the eyes are directed. When the eyes engage in narrow, targeted focus on a specific point, neural circuits responsible for concentration and goal-directed behavior become more active, creating a state of heightened alertness. Conversely, when the gaze is soft, unfocused, or constantly shifting, the brain tends to mirror that scattered state, making sustained attention difficult. Practicing deliberate visual focus, such as setting the eyes on a single object or visual marker while working, can help train the mind to stay anchored to the task at hand. Short periods of panoramic vision, where the eyes relax and take in the broader visual field, can reset the nervous system and prevent mental fatigue. Combining intentional narrow focus with brief visual breaks creates a rhythm that keeps the brain sharp, minimizes distractions, and strengthens the neural pathways that support long-duration, high-quality work. Breathing patterns have a profound effect on brain states and can be used to regulate focus, alertness, and overall productivity. Rapid, shallow breathing often signals stress to the nervous system, which can lead to scattered attention and reduced cognitive performance. In contrast, controlled and intentional breathing activates neural circuits that promote calm, balance, and sustained mental clarity. Techniques like physiological sighs, 2 quick inhales followed by a slow exhale, help reduce stress and reset the nervous system within moments, creating an ideal state for deep work. Slow, rhythmic breathing can also increase oxygen flow to the brain, enhancing its ability to process information and remain engaged in demanding tasks. By becoming aware of breathing patterns and adjusting them throughout the day, individuals can shift from a reactive mental state to one of deliberate control, training the brain to associate certain breath rhythms with focus. This consistent pairing strengthens neural pathways that support productivity while lowering the mental cost of maintaining attention for extended periods. Deep work windows are periods when the brain is most capable of sustaining intense focus and producing high-quality output, and structuring the day around these intervals can dramatically improve productivity. Research shows that the brain can maintain deep concentration for about 90 minutes before needing a reset as neural circuits begin to fatigue and attention naturally declines. During these focused blocks, distractions must be minimized, and a single task should be prioritized to fully engage the prefrontal cortex, which is responsible for planning, decision-making, and problem-solving. After each deep work session, a short break allows the nervous system to reset, clearing mental clutter and restoring energy for the next cycle. Over time, consistently training the brain to enter these states strengthens the neural pathways that support intense focus and reduces the mental effort required to stay engaged. Identifying personal peak performance times and aligning them with these deep work windows ensures that the brain operates at its highest potential for sustained periods of clarity and productivity.